Okay, this is Mr. Asher. I am going to go through and walk you through the Bornite problem, which is question number 5 from part 2 of the module 5 homework. So the reaction question is the reduction of Bornite. So we have 4 Cu5 FeS4 plus 19O2 goes to 20 copper plus 2 iron 3 oxide plus a bunch of sulfur dioxide, SO2. Okay. And the problem says well, my version, yours will probably say something different, 2.30 metric tons. So MT for metric tons of Bornite is reacted with excess oxygen. So this is how much Bornite there is. And remember, 1 metric ton is equal to 1,000 kilograms, right? Or 10 to the third kilograms. The only thing that's complicated about this problem is that you have to work through some units. But other than that, it's really relatively straightforward, just stoichiometry. And so when people get confused, it's mainly because they get flustered by the different units. So anyway, so we've got 2.30 metric tons. So we've got 2.30 metric tons times 10 to the third kilograms per metric ton times 10 to the third grams per kilogram, which is equal to 2.30 times 10 to the sixth grams, because 10 to the third plus 10 to the third, 10 to the third times 10 to the third is equal to 10 to the 3 plus 3, which is equal to 10 to the sixth. Right? Okay. So that's how much Bornite we have, 2.30 times 10 to the 6 grams. And then it says, how many moles of carbon atoms are there in 2.3 metric tons of Bornite? Well, first thing we need to know, if we need to know moles of copper atoms, I'm sorry, not copper, not carbon, copper atoms. Well, I give you the molecular weight of Bornite, the formula mass, and it's 501.88 grams per mole. So remember, if I have mass and I have molar mass, then I can get moles of Bornite is going to equal 2.30 times 10 to the sixth grams divided by 501.88 grams per mole. And so 2.3 501.88, and that comes out to be 4.58 times 10 to the third moles of Bornite. We'll call it B, right? And then if you look at the formula for Bornite, the formula mass, it's Cu5FeS4. So how many moles of copper atoms in there? Well, there were 5 moles of copper per mole of Cu5FeS4. Right? Because that's what that little 5 means. I have 5 moles of copper per mole of that. So that means that moles of copper is going to equal 4.58 times 10 to the third moles of B times 5 moles of copper per mole of B. And that comes out to be 2.29 times 10 to the fourth moles of copper. And then the next part says, well, what's the mass of copper produced? And then you have to take into account the yield, which is 83.1% yield of copper, which means that 83.1% of the total moles of copper is going to get turned into bornite, right? So 83.1% in fraction is equal to 0.831. So moles of copper produced is going to equal 0.831 times 2.29 times 10 to the fourth moles of copper, which is 1.90 times 10 to the fourth moles copper produced. Okay. And then the mass, I think copper is 63.546 grams per mole. Although I don't think that's particularly critical here. So 63.546. So mass of copper is going to equal the molar mass 63.546 grams per mole. 1.90 times 10 to the fourth moles of copper. And I come out with 63.54. Out with 1.21 times 10 to the sixth grams of copper, or 1.21 metric tons, if you will. Okay. So let me check and make sure that that is correct. Oh, here. Look at this. Yeah, and that would be the right answer. Okay. So, so that's how you do that one. It's relatively straightforward. Like I said, the point is just getting these units right. And so, you shouldn't have a whole lot of problems with this. Anyway, that's how you do the Bornite problem. We'll stop there. I'll talk to you later.